Here's a model of the energy storage products. So for the industry, the two main challenges of the energy storage system is the battery power loss due to mismatch of the cells and the potential hazards such as the fire and the explosion caused by the external forces, the high temperature, and abnormal battery operation, such as the overcharging and over-discharging. And the Huawei energy storage solution is an intelligent string-based solution. So as we mentioned at the previous topic, the maximum charge and discharge capacity is improved by 15% through the one pack optimization and one rack management. So Huawei's structure is very unique. And take a 2 megawatt hour system as an example. The annual battery power of the traditional solution is 5.45 million kilowatt hour, while that of the Huawei solution is 6.05 million kilowatt hour, increased by the 11% in revenue. Meanwhile, Huawei solution has 4 levels of protection. The first level is cell level protection, which supports the AI-based short circuit detection. The second is the battery level protection, means the pole voltage is 0 voltage. So when you do the installation, maintenance, and transportation, preventing the security risk caused by the accidentally touch. And the third is the rack level protection. So the multi-level intelligent linkage protection automatically disconnect the charge and discharge loop when the battery pack is like overcharging or the over temperature and like the overcurrent. These kind of scenarios, they will do the auto shutdown. And also the 2-level fault isolation of the circuit breakers and fuses, the anti-reverse connection and the insulation resistance detection. The last is the system level protection, which supports the combustible gas detection and the emission devices to proactively exhaust gases to prevent explosion, and the water detection and the linkage protection. So after water flooding, the system is shut off to avoid the electric shock. And here, this is this kind of a model of our 200 kilowatt hour system. So this kind of a system, you can see, this consists of the 12 battery modules, and the total capacity of this is 200 kilowatt hour. And also within this kind of cabinet, there's also a rack management system. So the structure is unique. There's a one pack optimization and one rack management, the structure, to improve our yield, to improve our usable energy of the storage by like 15%. So what if there's a high demand for electricity in the campus? The load is obvious higher than the solar power generation, and the electricity price is high. And let's learn about the solar storage charging scenario. So here is a case of the Huawei Shenzhen campus. The rooftop of this kind of campus is 8,000 square meters, and the initial configuration of the project is a 1 megawatt solar and 900 kilowatt hour energy storage. And Huawei optimizers are used to avoid the shadow of the HVAC devices on the rooftop. And more than 10% power is generated by installing the optimizers. And the installed capacity is also increased from like 1 megawatt to 1.1 megawatt, 10% higher due to the optimizers. And also from the energy storage, the proportion of the green power supply increased from like 58% to 64%. So at present, Huawei could provide the high quality core components, charging modules for charging stations. Huawei high charger charging module features high efficiency, high reliability, and high availability. And the Huawei high charger charging module has a wide voltage range. It supports a smooth evolution for charging piles from 500 voltage to 750 voltage. and even a future 1000 voltage. It is highly compatible with different new high voltage vehicles without renovation. And potentially it could save $2,818 per charging pile, protect customers' investment effectively. And also through the thermal field management and Huawei's patent wing-shaped fan technology, our charging modules support efficient heat dispensing and continuously high power output. Combined with Huawei AI flash charging, it takes less than 15 minutes to achieve from 30% to 80% SOCs. The potential VIP fast charging value-added services may increase the operator's revenue by $6,281 per pile each year. And in terms of the off-grid scenarios, Huawei launched the iPower Cube off-grid, like fuel removal power solution for all scenarios. The intelligent power platform, the PV power generation, and the intelligent lithium battery are used to replace the traditional DG power generation, achieving zero DG operation and zero carbon emissions. The 3 series of iPower Cube covers all scenarios, from small to medium to large cases. As we all know, 5G is booming. Up to now, 160 5G network has been launched around the world. But there are 2 challenges during 5G deployments. The first is high capex and high opex. The second one is the high carbon emissions. So the Huawei's one site, one cabinet solution has a high efficiency and high density design, which enables one cabinet to replace the 3 cabinets, improving the site energy efficiency to 90%. And also, if the one site, one blade solution is used, the site's energy efficiency can be improved to 97%. In addition, the solution requires no floor space, zero rent, and fast deployment within only like 1 hour. Digital acceleration and energy structure transformation holds new requirements for the site power supply. The first is a fast power supply. The second is a converged power supply. The third is a reliable power supply. The fourth is a green power supply. So Huawei Site Power built all scenario solutions in ICT scenarios. It's for communication, IoT, and ICT convergence stations. So Huawei iSuperSite solution can provide an outdoor working environment, power supply, security monitoring for ICT equipment. Next one is iPowerSite. iPowerSite is a one-stop solution for on-site perception scenarios. The stations provide the power supply and network backhaul, and for devices such as bullet cameras, drone cameras, and sensors. The data center industry is rapidly evolving, but faces great challenges to data center construction. Today it's my great pleasure to talk about the green data center facilities that embrace the carbon neutrality. So this is Huawei Fusion DC, the next generation data center facility solutions. The Fusion DC helps customers build future-proof data centers. So it's a modular and a prefabricated design, enables the TDM 6 months for like 1,000 racks and reduce the TDM by like 50%. And its construction mode is environment friendly, reducing garbage and water usage by like 80% and slashing CO2 emissions by 90%. So it uses the Huawei Fusion Core indirect evaporative cooling solutions to maximize the usage of the free cooling. The PoE will drop to like 1.2 in North China, so much lower than the traditional way. It also integrates with lots of smart features and AI-enabled energy optimization. The OM cost is like 35% lower. It fully complies with the international construction standards, has 50 years service life, and provides an earthquake, fire, waterproof design. So this is Huawei's new Fusion Module 2000 Smart Modular DC. which is mainly used in the medium and the large size data centers. The smart modular DC features a modular design, achieving the on-demand deployment and flexible expansion. This smart modular DCs was like Huawei Smart Lead technologies. So compared with the traditional lead-acid batteries, the lithium batteries have certain advantages, such as high density, saving the space by like 70%, and a long service life. In addition, a unified intelligent O&M management platform can be configured, so achieving the space, power, cooling, capacity, and asset visualized management. So improving resources utilization by 20%. So that's all the introduction of our products, and we welcome you to experience our solutions at the various Huawei reference sites to see how digital and ICT technologies transforms various industries in terms of energy generation and consumption. So that's all my introduction for today, and thanks for your time.
Thank you, Xiang. Let's welcome Mrs. Xia Yuxin, Marketing Manager of Huawei Smart PV, to present Huawei Function Solar Residential Solutions, enable a green and zero carbon life.
Good morning and afternoon, everyone. Welcome to Huawei SNEC 2021 Global Virtual Show. This is Michelle, Marketing Manager of Huawei Smart PV business. It's my great honor to guide everyone through the area today. This year, we launched the second generation of Huawei Fusion Solar Residential with our newly AI-based PV energy storage and consumption collaboration. We built this solution for zero carbon society and a greener house. This solution focuses on smart power generation and smart energy storage, also the system safety and our newly added smart power consumption. Follow me. Let us take a look at the smart power generation firstly. This is a 415-watt smart PV panel provided by our partner Huanghe Hydropower. You can see it is equipped with Huawei's latest 600-watt optimizer, which will be launched to overseas markets in Q4 this year. As you can see, the optimizer is installed at the back of the panel very easily. Look at the world map. Here you can see many optimizer application cases on different types of rooftops. To maximize power generation, one major advantage is the PV module level optimization, which can increase energy yields by 30% for the same rooftop configuration, as shown in this case located in Dongguan, China. Another advantage is that the impact of shading on PV efficiency is minimized, which means significantly higher solar capacity. Meanwhile, you can check on each PV module energy yields on our Fusion Solar app to know better about your solar system. Here is the Smart String Energy Storage System, the flagship product Luna 2000 battery. It was designed with residential scenario in mind. It is 1.3 meters in height, and each module is 5 kWh. Modular design allows customers to flexibly configure the battery capacity from 5 kWh to 10 kWh to 15 kWh. The system supports 2 batteries can be connected in parallel, which means the energy storage battery capacity can be extended to 30 kWh. Smart string architecture allows 30 kWh capacity, which you can rely on 24/7. Here you can see the battery pack. Each battery pack has a built-in energy optimizer. What's the function of that? You can see from the PowerPoint. The traditional mixer use of new and old battery packs cannot maximize the charge and discharge of the entire battery system due to the inconsistent internal SOH in any battery cell. So the capacity of the entire system is no longer than the weakest link. But the Huawei built-in energy optimizer can achieve the charge and discharge individually. Here you can see the comparison. We can achieve the energy usable up to 10%, and also the battery has 100% depth of discharge. You can unleash every last bit of energy. Another focus on the battery is our safety issue. We noticed some battery providers in the market had some explosion and fire accidents recently, and their products were also called back. But Huawei Smart String ESS can achieve the end-to-end safety protection. It has a zero voltage at ports for the safe operation and also the seal level monitoring in real time. Cloud-based BMS and AI-enabled health monitoring can identify the short circuits in just 20 seconds and disconnected them in 1 ms, covering the bursts and derivatives of the internal short circuits. The incidence of arcs with high energy causes potential fire hazards in PV plants, especially for the residential PV systems which are installed on the rooftop of our buildings that are very close to our residents. The fire caused by arcs will bring huge losses to the investments, assets, and potential safety of the owners. It is difficult to detect the DC arcing by the existing solutions in the industry, where frequently missed and false alarms, resulting in high maintenance costs and power generation losses. Huawei residential inverter uses a neural network algorithm to accurately detect DC arc fault and be able to shut down within 0.5 seconds to effectively eliminate potential fire hazards. And also with these optimizers, the solution can have a rapid shutdown function to zero voltage to ensure the whole safety of the house and people. You may see parameters when I am using the multimeter. The smart and easy operation and management is shown in this area. With this app, here you can see the real-time energy flow, enabling you to view the energy flow anywhere and anytime. Energy management can achieve easy control of power generation, storage, and electricity consumption. The component-level power generation monitoring redefines the management of the energy yield of each component. Today, we will also release a brand new digital future AI-powered PV, energy storage and consumption collaboration. We know that PV power generation during the daytime cannot be completely matched within user power consumption, resulting in only about 16% of PV power generation for cell consumption. And the remaining large amount of green power is wasted, which affects the IOI. The release of the AI optical storage and utilization synergy can effectively increase the self-consumption ratio. First of all, based on the big data learning of weather and user electricity consumption habits, AI can accurately to detect the future PV power generation and household electricity consumption, and AI can optimally control the charging and discharging of energy storage under the 3 different scenarios: sunny mode, rainy mode, and our smart home mode, to use the electricity to maximize the green electricity revenue in each scenario and effectively increasing the ratio of our self-consumption to build a green home and a green future. Compared with the 60% of pure solar to 85% of PV with storage, the household green power 2.0 solution combined with our AI optical storage synergy can further increase the self-consumption ratio of green power to more than 95%. Potential smart power consumption ecosystem partners are listed here. Huawei works together with our ecosystem partners to provide a smart home for a better life. The transportation industry currently accounts for nearly 10% of China's carbon emissions. To achieve the carbon neutrality goal, promoting the full electrification of the transportation industry will be an important step for all of us. Huawei mPower provides the end-to-end power solutions, including an onboard power solution and a charging infrastructure solution, to help OEMs build better cars and improve our users' experience. The onboard power solution includes the driver one in powertrain, a battery management system, and an onboard charging system, and a driver cloud intelligent management system. As for the charging infrastructure solution, it contains a wireless charging system and a DC fast charging module. During this year's Shanghai Auto Expo, Huawei launched its AI flash charging solution, a high voltage solution, which accommodates a front asynchronous in powertrain and a rear synchronous in powertrain, realizing a 30% to 80% SOC charging within just 15 minutes. This year, we launched the ArcFocus Alpha Huawei Inside versions to acceleration the time from 0 to 100 kilometers in just only 3.5 seconds. Compared with the dual synchronization solution, our four-wheel drive solution's NEDC efficiency can reach 86.6%. Such solution would increase the vehicle cruising range by 5%. Well, that's a short introduction of how we build towards zero carbon home and travel with Huawei Fusion Solar Smart PV Residential Solution, brought to you from SNEC 2021. We're looking forward to see you soon. Thank you.
Thank you, Yuxin. Now, let me introduce Mr. Haram Subramaniam, CTO of Huawei Smart PV Europe. He will be the moderator of our panel discussion. We will have 6 experienced panelists to share their intelligent ideas and thoughts about technology innovations and thoughts. The stage is yours.
Thank you very much, everyone, to join us in today's panel. There are a lot of listeners eagerly waiting to listen to some of our amazing panelists today. As you know, when we talk about renewable technologies, there's quite a lot of interesting technology behind it. And the way in which the renewable energy is generated, when we speak about PV, the PV technology, the PV generation technology, and the way in which the technology is constructed from a power plant, and the method used to transmit the energy, distribute it to the end users and to the load centers. Actually, it has quite a lot of, let's say, technical, deep, in-depth, sophisticated planning, and a lot of science and engineering behind. And obviously, innovation is going to play a very important role to define this renewable generation and to take it to the future. And for that purpose, to discuss this on what methods and innovations and topics from different people perspectives, to see how we can achieve the global transitions towards the goal of zero carbon society. We're going to talk today with our experts, some big trends in PV, trends in innovation to accelerate the technological advancements. And we're also happy to listen to some project experiences from some of the panelists today. So I'm Hariram Subramanian, in charge of PV utility scale projects in Europe, and I would be moderating today's panel discussion. We have today in our panel Mr. Heikki Siniharju from Fortum, Finland, who leads the solar technology team, and he brings in a decade of experience in developing renewable power plant projects business and also engineering and technology developments. Then we have Mr. Jaideep Sandhu, Director Technical Expertise Department from ENGIE, France, who brings a wealth of experience in renewable projects, O&M, and also in experience in construction, overseeing construction and technology development, and greenfield projects. We are very glad to have Mr. Olaf Salzwedel from IV Vogt GmbH, Germany. Mr. Salzwedel is the Director of Engineering in IV Vogt, and we are eagerly waiting to listen to the experience and expertise from a system integrator perspective and from an EPC perspective. Then we have Mr. Chris Buckland, Technical Director from Lightsource BP. Chris and his team have been responsible for overseeing quite a lot of utility scale power plants and PV projects, including incubating technology innovation into the LSBP BP projects. Then we welcome Mr. Felipe Fernandez, who is the Managing Director of FRVX and Engineering. In the panel, Mr. Hernandez have a wealth of experience in renewable energy projects, digital technology, bringing also innovation in market approaches and so on. So we are very, very glad to have this expert panel today. Actually, the panels have spent most of their entire career in energy and the PV industry in a variety of leadership roles, and we will listen to them on their thoughts and ideas on bringing the PV industry into the next future generation platform. Thank you very much, and we will go into the panelists. Now we have Mr. Jaideep Sandhu from the Technical Expertise Department. He's the Director of Technical Expertise Department from NG to share some of his thoughts and ideas on some very interesting topics that we will ask Mr. Sandhu. Before that, Jaideep, can you just give a brief overview of your role in your organization?
Yeah, thank you very much, Hariharan. So certainly, so I've been with NG for over 25 years, and as you mentioned, I currently head the Technical Expertise Department. Prior to this, I used to be head of operations for our international business line. In my current role, my team looks after business development support and operational support to the corporate entities and different business units, spanning a whole range of technologies. And as you know, very importantly, a lot of these technologies are renewable technologies. So we provide a lot of support on solar PV, on onshore and offshore wind, hydro, geothermal, battery storage, green gases, which is hydrogen and biomethane, for example. And of course, some of the more traditional technologies such as LNG and gas infrastructure, as well as thermal generation. But a bulk of our effort really goes into renewable technologies. We also provide support to the corporate side as well in terms of best practice guidelines and also supporting the investment process by having a review of the different investment files which come to our notice.
Brilliant. I think, I mean, as you said, focusing more towards renewable energy, and when we go a little bit towards the utility scale solar here, what do you think? I mean, how was this utility scale solar now compared to, let's say, 5 years ago? Have you seen any, let's say, groundbreaking changes here?
Yeah, a lot of changes. So firstly, when I started looking at solar quite some time ago, but in real earnestness in 2015. So that's almost 5 years ago. And we've seen a lot of change. In NG itself, we had 197 megawatts of solar capacity, the solar PV capacity at that time. Today, we got over 3 gigawatts in operation and several gigawatts under construction. So big change in the way the technology has taken off. And in terms of what we've seen in the field, what we are seeing is improving performances and efficiency, much larger projects, also some hybridization with batteries or even with wind in terms of commercial offerings. The modules themselves, quite a lot of change. So, you know, it used to be polycrystalline, now it's all monocrystalline, the bulk of it. Also with bifacials, increasing energy densities, use of trackers, etc., to increase the yield from the plants, cleaning robots which help with O&M strategy, and very importantly, even on the inverter side, on the electrical system side, increasing voltages. So currently the voltage is 1500 volts. We expect this to rise further in the future. Also, in terms of connection to the grid, there were more and more rigid requirements are being imposed by the transmission system operators to connect to the grid as the percentage of renewables is increasing on the network. And we see that the technology is trying to keep pace, and in fact is keeping pace with the ease of connection to the networks. So a lot of change, I would say, over the last 5 years.
Brilliant. I mean, what I have always, noticed is that very important stress is done on the reliability, especially at the power plant level and also on the technology. Obviously, we are moving into new technologies, new material science, and more control aspects done in software and so on. But, we can't wait the next 20, 25, 30, 35 years to see what's happening. But what are your assumptions? I mean, what is to be done, or what will happen in the reliability and the lifetime? Are there any gaps that needs to be filled by the industry, especially from an OEM suppliers?
Yes, so when I look at what we need for reliability, availability, performance of the plant, as you can imagine, a solar PV plant is almost like an infrastructure asset which is sitting there. So people are looking at extended lifetimes of 35, even 40 years now going forward. So you want your plant to be reliable and available and perform to what your expectations are over this period of time. Mm-hmm. So several things have to be managed in this. So the modules have to be of the appropriate performance, degradation, etc. So it's much more predictable in terms of what we can expect the plant to do. In terms of inverters and the electrical systems, how do we manage to ensure that the equipment is reliable over this period of time? Is it working appropriately? Is it easily maintainable? So in terms of lifetime management as well. So what can we do to address obsolescence and also to avoid electronic waste, which is becoming, as you know, an important subject? What can be done to keep repairing this equipment rather than having to replace it over a period of time? So all of these things are extremely important for the long-term sustainability of the industry and for our business models going forward.
Very interesting. I think when we talk on this topic and when we compare the industry, let's say, to the most popular one, automotive, there are already reliability standards. But in PV, I think there should definitely be some leadership role be taken and to quantify reliability. What are your thoughts there? I mean, is there a gap? Should the industry need to bring in some reliability standardization?
Yeah. So when I compare the PV industry, there are a number of similarities to the automobile industry. So a lot of the quality assurance standards, for example, are very similar to what you would see in the automotive industry, given that it's a very repeatable process of installation. You install millions of modules in the same structure. So there are lots of things which we can learn from the automotive industry. So firstly, when we look at what can we do, obviously it's about the development of the product, the certification of the product, making sure that the products are certified to an appropriate standard, which, by the way, happens, but then you need to make sure that the bills of materials are consistently maintained in the supplies, which are then instituted subsequently. So ensuring all of that. And what we would expect from the manufacturers in this case is also work with us just the way, let's say, a lot of the automobile manufacturers work, is in terms of making sure that there is the service support available over the extended lifetime of the equipment. Also, when we are looking at type faults or serial defects, these are identified early and remedied early, just as they do in the automobile industry. At the same time, we are looking at a lot of evolution taking place in terms of automation, standardization, operating methodologies, which take away the element of human error in the system, and also to optimize the asset performance to the extent possible, just as you would have different systems in the car to doing that. So we would expect those things to also become more standardized and almost a given in these types of assets. So yes, in summary, expectations to have the same kind of lifetime support which we see in the automotive industry, the quality standards, the standardization of the process, and the serial defect and latent defect addressal at an early stage, along with, of course, the implementation of more digital and smart systems and controls in the process.
I think I totally agree to your points here. And from the power electronics perspective, we are also looking into the same direction, bringing in, let's say, extreme amount of robustness rather than just mentioning it as reliability. We also bring another two terms, which is the robustness, because you have the grid, the system have to perform with different grid disturbances, and at the same time also to bring in high amount of resilience to the power plant, because as you said rightly, we are speaking 30, 35, and sometimes even beyond, to build a very sustainable plant so that there is less waste created. And I think this is very interesting thoughts. Thank you, Mr. Sandhu, for sharing.
And
your
if I could just add
please.
one thing, also very similar to the automobile industry. The one thing with PV plants is it's all outdoor. So that extra resilience is also required, recognizing the environmental conditions in which these plants operate. And again, there's quite a lot of learning from the automotive industry there as well.
Absolutely. I mean, that's also what we are looking at, different mission profiles, different conditions. Project in Europe, when we look into the same technology being used for projects, let's say in Middle East or in India or in some other countries with robust environment conditions, I think reliability plays a very important role, and that should come from technology and also the best practices, as you said, like standardization with and finding out the, let's say, service platform and support throughout the lifetime of the power plant and so on. Thanks a lot, Mr. Sandhu, for sharing your thoughts and insights. Very insightful, and we are very glad to have you today in the panel. Thank you very much.
And thank you very much for having me. It's been a pleasure.
Now we have here a very interesting participant in our panel, Mr. Olaf Salzwedel, who leads the engineering team. He's a director engineering and system integration from IB Vogt GmbH, a German company. And we would like to understand some thoughts and ideas from Mr. Salzwedel, especially on, let's say, the topics that is related to EPC and how an EPC and the developer would look into OEM and innovations. So a question to you, Mr. Salzwedel, is from the technical side, we are also looking into the EPC activities, quite a lot of activities from planning, procurement, taking the right decision for the technology. Then comes engineering design, construction activities, managing the field staff, subcontractors, etc., etc. So what are the challenges faced by the EPC in the solar industry?
So obviously there are a lot. So we face on a daily basis, since we are a system integrator, and you mentioned where we are active and the fields we look into. And obviously, as an integrated developer, we try to maximize the value of projects in our best interest and the customer's interest. And we spend a lot of effort in achieving this in our projects, for example, from engineering perspective. But we are not alone in the field, and we provide certain input for the optimization of projects. But you asked for difficulties in these days, mainly, I guess, and this comes from my perspective, not especially from the engineering world and products. We'll come to that. So pricing obviously is something which is under discussion also in our organization in terms of modules, raw materials, steel, etc., etc. And this impacts our projects in a way, so that we have to consider the options, let's say. When it comes to the engineering perspective, so projects in the past used to be simple from my perspective. Looking into the module side of the business, we were able to exchange modules right before start of construction because products seem to be similar. Now we are talking about something what we call internally the module zoo, because of the various options, and this makes life complicated for the engineering team inside of our organization. So module decision impacts design, and this is what happens quite often, to be honest, and makes life complicated. But from company perspective, challenges at the moment: module pricing, steel pricing, and the impact for the projects.
Understand. I think, as you said, a very interesting term like module zoo and module affecting, let's say, the technology decision as well. So we are also now moving into large current modules, lower VOC kind of modules, and some innovations are being seen in the industry as well. So are there any key points from the OEM perspective, from, let's say, from the technology provider perspective, that is needed to fill the innovation gap, or there anything missing that will help you build power plants much better?
So what is much better? Yeah, that's the question. Yeah.
Yes.
So cheaper, higher yield, please. More DC capacity on the field without impacting the yield too much. So this is what we are looking for, and higher efficiency modules certainly help in this regard. So different module technologies we consider in our projects. Honestly speaking, I cannot recommend what to develop, because we are not developers, so project developers, but we do not develop equipment and material, etc., etc. Anything which helps to bring down prices. This is standard answer from everywhere, I guess. And important for us, also for the future, and even more in the future, is since we operate plants and guarantee performance ratio, availability also in long-term O&M contracts. We are keen to consider products in our projects which allow the highest availability, because this is key. Yeah, so the yield predictions, for example, internal and external, proved in the past that our designs and the realized projects meet the expectations as long as there's perfect availability. So any product which brings down availability must be considered to be a bad choice. Yeah. So this is what we are looking for: durable products.
Yeah. Understand. So I think the key takeaway is to look into product, let's say, availability, high reliability, and also focusing it around the modules. But since you are in this field of EPC activities, system integration, how quickly do you think any new technology can be absorbed? Is there a risk for you, or for your customers, or do you think you could immediately try something new? What would be the case?
Yeah, so
generally speaking, yeah.
So generally speaking, we say we are not the first movers in certain technologies, and we try to understand first what does it mean to us. We have set up a couple of years ago a small team called Technologies and Applications. And the small team looks into the latest developments in the market, and from our perspective. And new technology is considered to be something which we did not yet consider in our projects. So several years ago, when trackers used to be new to us, we started to look into this, to dig into this, and to understand what the implications are for us. And later on, bifacial modules, also from the past, floating PV, agri PV, these things, and we spend effort on this in order to understand what does it mean to us. And once we understand something, then we are in a position to consider this in our projects. And thereafter, once considered, we spend again effort in order to check whether our assumptions were right, especially concerning, so we have tracker experience in the meantime, and we also looked into bifacial module installations and checked our assumptions, and this is how we approach this. Yeah? So we do not just take something from the market and give it a try, but we investigate, we look into this from a technical perspective, we check, we simulate, we integrate in our designs in order to understand what does it mean, and certainly impact for the financial modeling.
Yeah, I understand completely. So
So
I think
this
please go
means
ahead.
then that we are, so we work on this and try to find a way to integrate things into our projects once we understand that it must be beneficial. Yeah. And the same applies obviously for battery energy storage systems. We look into this in several years. Yeah, so we are in a position to work on this. We do this. We have our team also together with procurement, obviously, looking into this to understand the topic and then integrate in our projects. And therefore, we are willing to look into this. We are active in this field.
Very interesting. I think the key takeaway is, I mean, when we look into, let's say, a leader in the EPC field, a very, very deep technical due diligence is needed on new technology that comes in, and then understanding this from various aspects on the new technology, like investigating the yield assessment, reliability, the product, etc., and how it will impact your company as well as your customer into the lifetime of the power plant. I think this is a very good key takeaway, and I think that's also the way the industry is driving towards, to come up with high reliable products, but at the same time bring opportunities and possibilities for companies like you to do a deep technical due diligence to understand the depth of the product from the module to the, let's say, to the substation or wherever we are linked in. Perfect. Thank you very much, Mr. Salzwedel, for sharing your thoughts and ideas from the EPC perspective and system integrator perspective. These are very valuable inputs, and I think this will be very useful for our listeners to understand the perspective on the field as well. Thank you very much.
Thanks a lot.
So now we have here Heikki Siniharju, who is the head of solar technology, Fortum, from Finland. Mr. Siniharju will share some of the interesting thoughts and insights on some large, very interesting power plants that has been built with bifacial and monofacial, and also some thoughts on how the PV industry will take on. Here, Mr. Siniharju, we want to get your feeling first. What are the exciting developments you have seen in the PV industry in the recent years?
Good, thanks, and thanks for having me here. So super excited, and thanks for the invitation. Well, from my side, of course, it's important to start with the fact that solar is the most cheapest electricity generation source as we speak. So that has been tremendous excitement and development, and we have a clear technical roadmap that this continues taking place. So this, of course, makes me super excited. At the same time as we speak, so I'm very, very kind of curious and excited about the opportunities to integrate PV with the batteries, with the electrolyzers, and gain the synergies both from investment and operational point of view. And then, of course, more standard technical dimensions like bifacial modules, of course, developing property cleaning, string inverters, gaining more and more momentum, and there, of course, this plus minus 1500 volt design. So those make me super excited.
Yeah, absolutely. Very interesting. I mean, I think one exciting thing is also your large scale, ultra megawatt scale project with string inverters in India. I think this is the Jaisalmer India project with bifacial, some percentage, and with monofacial. Are there any interesting things that you have learned in this project, or anything you want to share on this project as well?
Sure. So yeah, the Jaisalmer 333 megawatt project has been a super important project for us, and of course, most importantly, that we have been able to now implement it in safe, sustainable way on time and budget in these quite challenging times, I would say. And of course, that's a lot to thank our great Indian colleagues and our global partners. But then from technical point of view, it has been exciting projects. We have went first time big way with the bifacial modules there, with the string inverters as well. And then once again, we have implemented a fully dry cleaning solutions or robotic cleaning solution in this plant.
Mm-hmm.
So, from technical point of view, it's a very interesting project as well.
Oh, very interesting. So you are already taking AI technologies to the next level to bring in O&M efficiencies. I mean, this is a very big, huge project in India. And so what is the trend and what do you think will happen? Do you think there'll be large scale single sites or multiple single sites of smaller scales? What do you think? Do you see any economy of scale building a large scale? Let's say you want to build a 1 gigawatt plant in the future. Do you want to break it down into 10 pieces of smaller blocks, or you want to build it like bulk, big 1 gigawatt? What are your thoughts on this?
Well, of course, to start with, so of course there are economies of scale, so both in the operations and in the investment, but the delta gets a bit smaller and smaller when you start to go above the, let's say, 100 megawatts. But this is, of course, at the same time very market and case specific. So, for example, if you have a really high connection grid cost or some other one-time high DevEx cost, so of course, bigger you build, so this one-time item basically disappears. Then I would say that we have been building big plants in India. This has been quite of a market opportunity as well. And now when we start building more and more projects to Europe, so the average size would naturally come a bit down.
Okay, quite interesting. I mean, that's also something we have been trying to look into it. How would the large power plants will be in the future, or the futuristic large power plants? Are there any wishes that you want to say as a pioneer in solar industry? What changes you want to see in the industry?
Well, I think that now over a decade of work in solar, so I have seen a lot of changes, and I've been super happy about them. Like an example, that when we started auditing about 10 years ago, our manufacturers, so they were a bit surprised when we brought a long list of sustainability questionnaires and inspection items, and today these start to be industry standard practices all over the place.
Yeah.
At the same time, as a most sustainable electricity generating source and an industry, take care of that we are sustainable in all the parts of the project value chain. So, for example, we should be using in a water scarce and dry locations water to something else than panel cleaning, and luckily even there as well. So the dry cleaning solutions and robotic cleaning solutions start to be rather industry standard.
Yeah.
But then where I of course see that we can always be better and we should be better is that the drumming the drums in the political scheme. So we need everybody to know that this is the most sustainable electricity source, and the political decision makers all over the world that give their support for of course for a solar, for the renewables, but for the whole green transition.
Yeah, so I think we are in the same thoughts like you. I mean, environment, health, safety, and sustainability is one, let's say, fundamental building block, and above it comes, let's say, the power plant, the electrical disciplines, and so on. And as you rightly said, like dry cleaning, which you have already, I think you have done that in the project in India, right, with the dry cleaning. So I think this is going in a very good direction to bring more sustainable practices in a large-scale PV power plant. And thanks, Mr. Siniharu, for your thoughts and sharing us your very valuable inputs. And it's always a pleasure to speak with you, and nice to have you today in our panel. Yeah, thank you very much for joining.
Thank you.
So also in the panel, we have Mr. Fabrizio Bizzari, who is the head of solar innovation from Enel. Mr. Fabrizio Bizzari have a wide experience of more than 25 years in engineering and construction, and also a lot of experience in the R&D. Mr. Fabrizio Bizzarri was one of the key person involved in the construction of the first bifacial SJT factory in the world, and he's managing innovations and R&D topics with Enel. We wanted to ask one very important question from the innovation side. As we are speaking now, various technologies, we are talking about grid-tied inverters, and we would be having in the future technology that can do grid forming. So, Mr. Bizzarri, what do you think is the key technology needed and the use cases for grid forming, and what kind of scenarios you are looking for with grid forming type of inverters in the future?
Sure. Thank you, Hariram. I think that in the past, grid forming requirement was only concept just for small scale system and island system. So small hybrid system that have not connection with the grid. With the grid, or they was just connected with a small grid and weak grid. Nowadays is more important is always a growing of plant connected to the grid, and thinking to the future in which we will have a big percentage of renewable plant integrated in the grid. We have to think to something to maintain the control and the grid stability. So how we can maintain the grid stability, thinking to renewable penetration that are more or less even more than 60%. We are talking about in Europe, for example, there is a program in which we are talking about the completely integration of 100% renewable energy. So thinking to that kind of future, we have to understand, we have to fight with some challenges that are affecting the stability of the electric grid. So in this context, we are just operating in some countries in which, for example, there is some issue. Thinking to Australia, for example, we know that we already have an higher penetration of renewables. And so in this context, we are just operating, thinking to solution to maintain the stability of the grid. In this sense, for example, we are just facing with issue and topics typically of a grid forming inverter, like frequency control, voltage control, system protection, fault ride through and voltage recovery. And so we have to model and simulate this kind of working of equipment. So it's important for us to thinking in the future, because our plant are bigger plant of more than sometimes even more than 500 megawatts. So approximately sometimes we are thinking to plant even bigger. And in this kind of plant, I think that we will have the need to imagine a working of the inverter that is the core of the PV plant, like having this kind of inverter that have a behavior like the synchronous generator with a large rotational inertia, we know. And so we are thinking to something that can even imagine to manage this kind of issue as like a typical generator. So we are thinking about inertial, synthetic inertial, for example. We are fighting with all the things related to the sun specification of the grid, because we can imagine that in the future we have to even to fight with the secondary regulation. And so in that case, it could be very important even to work together with the storage system inside the plant. And so thinking to hybrid system, which there is the storage inverter that can make some activities that we call grid forming activities integrated with this kind of hybrid plant.
Very interesting, Fabrizio, because we are talking about, let's say, technologies that will bring in 100% of renewables in the grid. And you mentioned Australia as one of the key challenge where grid forming capabilities are very important. We are also seeing, let's say, needs for grid codes to satisfy grid forming technologies. For example, what are the capabilities of grid forming methods like harmonics as a sink? What is the short circuit current contribution from grid forming, etc.? Do you also see business case for grid forming in Europe, Mr. Bizzarri?
Yes, I think so. So thinking to the Europe, I told that we are thinking to reach in 2030 a very challenges penetration of the renewables. And so there are some countries, for example, in Spain, in which there is even this kind of issue, thinking to the, for example, the energy management. Today, we are even, we know that in Spain, there is even a strong regulation considering even the approach, the forecasting of the nowcasting of the renewable energy, especially for the wind and solar. And so it became very important to not only adapt the functionality of our plant, but even thinking before the construction of the plant, how we can contribute to the stability of the grid. And so obviously the inverter is something that will be key for this kind of the generation. So obviously we know that inverter is key even for other renewables. So in the future probably the domination will be essentially from generator that have power electronics on board. And so I think that could be very interesting to have a kind of generator, even in a big plant, in a bigger photovoltaic plant, that can manage in a very small piece of the power the different services that they can do for the grid. So sometimes we are talking about centralized system to manage the interface with the grid, but obviously having some kind of inverter that can manage this at small power could be very good.
Perfect. I think this is also one of the directions where we are looking to bring in solutions with the grid forming technology, as this is one of the key area where we wanted to have the power electronics and the control together with the storage to create concept very similar to virtual synchronous machines. And thanks to Enel also having similar ideas and thoughts so that we can all attain the 100% of renewables, not only in Europe, but also in various countries with PV technologies. Thank you very much, Mr. Bizzarri, for sharing your thoughts and ideas in the panel. And I think our listeners might have got very valuable input from you today, and we will see a lot of sustainable renewable power plants in the future. Thank you very much.
Thank you very much, Argam. Bye.
So now the question to Mr. Chris Buckland from Lightsource BP. So welcome, Mr. Chris Buckland, to the panel. Mr. Buckland, we have some very interesting thoughts here as we want to know about some technology and innovation. So as you know, for the energy transition, we need more of everything. We want to have better grids. We want better technology from the power electronics, inverter, maybe AI technology, storage technology, new markets as well. Do you think virtual power plant could unlock the potential here, or do we still need to think more like large utility scale power plants, or also focus a little bit in Europe on distributed power plants with micro generation, small and medium sized power plants? So what are your thoughts in this, Mr. Buckland?
Thanks very much, and thanks very much for the invitation today to participate in this event. I think realistically, the ambitious goals that we have, 2050 and within Europe probably even earlier, going for the carbon neutral aspect, we're going to need that and everything else together. So ultimately, whether it's the large scale utility plants and or very small scale and aggregated domestic and the commercial industrial, all of these will need to work together. And then that is actually where we come back to the AI platforms. The question is, will the AI platforms almost be ready on time? There is not a golden solution out there. There isn't the Google of AI platforms as far as energy is concerned, those kinds of things. And of course, we have batteries to deal with as well. And if we talk about batteries, then maybe one day we have vehicle to grid. So everything needs to work together. C&I, commercial, industrial are useful, but they tend to be subscale. Basically, a manufacturing facility generally can't have enough solar panels on its roof, which means that then the solar panels are adjacent to the facility. That's the kind of PPAs we're doing here in the UK and elsewhere. But generally, it's going to be a lot of all of the above, plus the wind. I think the interaction between solar and wind also needs to be taken into account. B2G we've mentioned. Clearly, most of the storage, lithium-ion storage, is going into vehicles. Most of those vehicles will be parked up. Now, there are two V2G areas I think that are interesting that we are seeing in the market. One being the domestic, but also let's say the delivery lorries, the post office vans, and the subscale. So all of these storage units will be exceptionally helpful for moderating the inherent variability of solar and wind as you put them together and as we aim for this carbon neutral world.
Very interesting. I think you touched on storage, battery and technologies, and also EVs. Do you think that, let's say, in countries where there are a lot of demand to have huge data centers, they have, like, for example, in Ireland or in some other countries, do you think if the data centers would participate also in the ancillary service markets, do you see that as, let's say, a potential competition for the PV as well, when PV plants would also service and provide some ancillary services? What are your thoughts here?
Short term, certainly, and within the UK, as you may be aware, that DSR, demand side response services, are already being monetized. We're seeing those demand side response services now spreading across Europe. Italy already is relatively clear, and Spain probably not too far away. So DSR, demand side response, turn down in association with turn up, is definitely a solution. Of course, ideally, we would all have pumped storage, and that would just solve the problem for everyone. Fine in Norway, fine in Austria, probably. But the majority of the world, we're going to need to buffer off that energy in a shape or form. Longer term, which you're probably aware of, we're working together with our big brother, BP, looking at the green hydrogen solution. So when solar can produce green hydrogen, we then have an energy form which can then be released as and when it's needed. Again, coming back to this intermittency, although predictability, of the renewables energy sector.
Yeah, very interesting. I think with hydrogen, I think one could even plan for a long-term storage and buffer the gap. Very interesting, very interesting. Thank you very much. Let me ask you a question from, let's say, from the lifetime construction and quality, because a lot of our listeners are also interested to get your opinion on that. So actually, when you look into a power plant, obviously you have the equipments, and you would go for qualifying the equipments and also on the construction quality. plays an important role when we talk about availability of large-scale power plants over the lifetime. So what would be some key KPIs that you want to generally look into the selection of the equipment and even as a general contractor? And are there any lessons learned from you? You want to share that to our listeners? Lessons?
Absolutely, and as you know, Lightsource, we've been in this space for 10 years now, or slightly more than 10 years, and delivered more than 300 solar plants. So believe you me, there are enough lessons learned. I think we have to start definitely with the safety, the safe operation and construction of these sites. That's an absolute baseline. And so companies, when we're looking at onboarding new equipment or indeed new products from established providers, then one of the first steps that we go through is the compliance and our confidence in terms of the safe operation of that plant and the delivery of that plant. The other thing I have to say that we look at, even with established providers, with a good Bloomberg rating and with good distribution across the market already, is when a new product comes online, we go through almost the same process in terms of qualification as we would for a new supplier. Now, it is true to say that at Lightsource we are agnostic, so we will go to market for a qualified provider. We don't have lock-in with one or two providers, either on modules or on the inverter side. So we start with health and safety. We start with the confidence that this new product or this new supplier will be able to deliver the technical solution. And then, of course, we have to look at the commercial aspects, because there's no point in buying something that ultimately, over its lifetime, and I would focus on the lifetime cost of these plants, where it's less competitive. Lightsource, here we're moving from 30 to 40-year lifetime on the solar plants. So longevity of a product as well as its warranty, but the longevity more than the warranty, definitely drives a lot of our discussions, particularly interesting enough once you get beyond the 30-year lifetime. So string inverters, possibly we would have over a 40-year lifetime a slightly higher replacement rate than a central inverter, for example. Nonetheless, maintaining a site with string inverters, such as from Huawei, is intrinsically more cost efficient because you can deal with that with a easier logistics flow than trying to maintain or refurbish established central inverters. So health and safety, reliability and confidence building, then it's the costing and the pricing over the lifetime of the project, not just at the upfront costs. And that, I think, is important, together with the real support that we will then get from these providers. In the best will of the world, you will get a very good quality module, very good quality trackers, inverters, but things do go wrong because we deploy so many millions of them. And having that ability to engage with the manufacturer, for the manufacturer to have local support in the right time zone, and evidence of response, and that's definitely a lesson learned. Evidence of response of a manufacturer supporting us in the operation of these sites definitely plays a role in follow-on business.
Brilliant. So I have very key takeaways also for us and also for a lot of listeners, like health and safety, reliability, evidence of response, quality, and looking into the lifetime of the product and the project. So there needs to be quite a lot of technological innovations that would also address these things. For example, like conditional-based maintenance methods, so that maintenance can be done with more, let's say, technological evidences and so on, rather than making a periodic process. Thank you very much, Mr. Buckland, for your thoughts and insights. Very valuable, and it's a pleasure to have you in our panel and to know your ideas. And thank you very much once again.
Right. Appreciate the time again and the opportunity to suggest some insights from what we have on this side of the pond. Okay.
Thank you. Bye-bye. So now we have Mr. Felipe Hernandez, who is the Managing Director of FRV Action Engineering. So the question to you, Mr. Hernandez, is What is the technology trend and the biggest challenge of utility scale storage solution from your point of view? So what are your thoughts in this? We would like to have our listeners enlightened with your feedback.
Okay, first of all, thank you to Huawei to invite to take part of this panel. It's an honor to share this time with you. So talking about the technology trends, I think that is the time to integrate the storage with the power generation. At the moment, some solutions, some projects have been done, but it was not really integrated. Most of the times, you take a BS solution that is connected in medium voltage, but it's like some kind of external connection of a battery to the system. It's not fully integrated with the generation of the project. So my feeling is that the next step should be this kind of DC coupling, where you are able to connect the batteries and the modules to the same electrical equipment, to the same inverter, power conversion systems, in order to manage in a more efficient way all the energy flows that we are doing today.
Yeah, I think it's very interesting because DC coupling will also avoid, let's say, or will improve some more efficiency in the system. And DC coupling could also be a strategy that will not load the grid too much because you don't couple again in the medium voltage or in the HV side. And I think we are having similar thoughts like how you are thinking on the DC coupled solution. But what do you think about, let's say, some revenue streams for battery storage? Obviously cost is a pain point, but we need some revenue streams as well. Do you see this solution with DC coupled deployed, let's say, in what size and which parts of Europe do you think is interesting as well?
I think the key is try to define the system as flexible as possible, because it's what will allow to you capture different revenue streams. Now, depending on the countries, there are different very interesting streams. In some areas, energy arbitrage. In other areas, you can manage the frequency service, the ancillary service. But it is in a very quick evolution change. So really, no one could guarantee what will be the main revenue stream in 5, 10, 15 years. So what we try to do is we try to define very flexible system that will allow us to evolve with the markets and the technology. So maybe sometimes we will be playing in ancillary service. Maybe other times we will do peak shifting with the DC couple. Another time we will play directly to energy arbitrage, moving the energy from the midday when we start to see very low on market price to the evening. So I think the key will be on this side. In flexibility, have a system that is able to be very flexible to take all these different options. Some of them we don't know yet what will be, and also a very power software that allows you to do all this energy and service management. And it's where the difference will be done in how you use your system, how you are able to read what is happening in the grid to take this revenue stream.
Understand. So which countries do you see maybe interesting in Europe as we might go on this ancillary services, peak shifting and so on? Spain, for example, or Spain, south of Europe or north of Europe?
Yes, south of Europe will come. There are a ambitious plan in Spain to deploy storage in the next year, or also in Italy. But there are markets which regulations still evolve yet. Right now, in the short term, for us, the best market is not a promise, it's a reality, is a UK. We have already a couple of projects under operation, storage projects in UK. We are going to do a very big one in the next months. So it is a market that has evolved, has a strong commitment from the authorities to get the net zero grid in a short time. So they have defined very attractive market for this kind of flexibility service. That what means is that right now the storage is a viable solution with not any kind of public support, just relying on the market revenue stream. So right now, UK is the most interesting country, and in the midterm, probably South of Europe will be take this leading role.
Yeah, very good. I mean, I think very interesting to get your thoughts and ideas here. And I think storage is one important necessity to have this global transition with, let's say, renewables, and to achieve the 100% renewable target that everyone is looking, and to bring in the goal of zero carbon, let's say, smart society. Thank you very much, Mr. Hernandez, for joining and enlightening us on the very, very important topic related to storage and what we will see in the future and which markets will be interesting for us, let's say. Thank you very much.
Thanks to you for sharing this time. Thank you.
Thank you. Bye-bye.
Bye.
We had a very interesting discussion today with our experts. Got very deep insights on the technology innovation, as well as how the PV industry will be leading in the next years and days to come. Solar energy have come quite a long way, but as we have understood from our panelists, there is actually also a need to bring in much more reliability, resilience, and bring in concepts like grid forming technology coupled with storage solution, and also to bring in a very high amount of robustness in the power plant, because in the end, after all, everyone is looking towards LCOE and together with the storage on the LCOS. So we also need to have digital technologies inside the PV plant solutions. We have seen, for example, from one of the panelists talking about robotic cleaning. So we would have more of AI-based technologies in the PV power plant. Grid stability is getting more and more important. Operation under weak grid situation with a large amount of penetration of renewables is getting also imperative. So I think in the panel discussion, we have got a variety of insights. Thanks a lot to everyone for joining today in the panel. And I believe it has given a very good, let's say, understanding also to our listeners from the industry stalwarts here who have joined. Until then, I'm looking forward to the next discussion with similar panelists. Until then, thank you very much for joining, and thanks for making this panel discussion very successful. Thank you very much, everyone.
Thank you so much for joining and staying with us. We are almost at the end of today's event. It is our great honor to have you today to witness the SNEC 2021 online and how Huawei continuously builds a better, green and smart world. Thanks for your time and wish to see you next year in SNEC 2022 in Shanghai. Stay safe and sustainable. Take care and goodbye.